Welcome to The Explainer. So, we're living in this world just flooded with powerful AIs, right? But that begs a really important question. How do we actually know if they're getting any smarter?
I mean, you hear all these names thrown around, GPT-4, Claude, Gemini, and they're all super impressive, but how do you really measure one against the other? Like, what does smarter even mean for an AI? Turns out, it's way more complicated than you'd expect.
So the most straightforward answer, the one most people jump to first, is to do pretty much what we do with people. You give them a test, a standardized test. And in the AI world, these have a specific name, automatic benchmarks.
Okay, so what are these? Well, you can think of them as the SATs for AIs. They're these prepackaged exams, a whole set of questions and tasks that every model can take. This lets researchers grade them on the exact same scale, and then, line them up and see who comes out on top. It creates this big leaderboard of AI performance.
But here's where it gets tricky, right? This is the big dilemma. On the one hand, these tests are great. They create a totally level playing field. You get consistent results you can trust and reproduce. But, and this is a big but, a great score on a test doesn't automatically mean the AI is going to be any good out in the real world. We all know someone who was great at taking tests, but struggled with the actual job, right? It's kind of the same thing.
All right, so let's take a closer look at these tests. And yeah, just like in school, it's not just one big final exam. Nope, there's a whole bunch of different subject tests, each one built to measure a totally different skill. First up for general knowledge, we have the MMLU. It's a mouthful, stands for Massive Multitask Language Understanding, but really you can just think of it as the ultimate final exam for an AI. It covers a crazy range of topics, 57 different subjects, everything from science to history to law, to see if the model has actually learned stuff, not just memorized it. Okay, what about math and more importantly, reasoning? For that, you've got benchmarks like GSM-8K. Now, this isn't your simple 2 plus 2. We're talking about those tricky multi-step word problems from school that required you to actually think. The whole point is to see if an AI can logically work its way through a problem from start to finish.
And then there's coding. This is a big one. For this, we have HumanEval. And I love this one because it's so practical. It doesn't care if the code looks pretty. It actually runs the code the AI writes against 164 different problems to see if it works. Does it pass the tests? Does it do the job? That's all that matters.
So this really gets to the heart of the matter. Acing these academic tests, it's absolutely impressive, no doubt. But it's just not the same thing as being good at a real-world job. You can have a model that's a total genius at trivia, but that same model might be completely useless or even dangerous in the hands of a doctor trying to figure out a diagnosis. So because of this exact problem, researchers realized they needed to think outside the box. They've started coming up with some really clever, innovative ways to measure performance that go way beyond just, a simple test. One of my favorite new methods is called LLM as judge. And it's pretty much exactly what it sounds like. You take a really powerful, top-tier AI, think something like GPT-4, and you use it to score the answers from other AIs. It's brilliant. It's basically like asking the valedictorian to grade everyone else's papers. And then there's something even wilder, evaluation arenas. This is probably the most fun way to test AIs. It's basically an AI cage match or a talent show. You pit two anonymous AIs against each other, head to head. They both answer the same prompt, and a real person, you, gets to be the judge and vote for the winner. And here's how it works. It's beautifully simple. You go to a site like the chatbot arena, you type in any question or prompt you want, and boom, you get two answers side by side from two mystery AIs. You read both, and you just pick the one you think is better. That's it. And when thousands of people do this, you get this amazing leaderboard based purely on what humans actually prefer.
Now, this crowdsourcing approach is awesome for capturing what real users find helpful. It tests the models on all sorts of weird, creative questions. But there's a flip side. The results can be skewed depending on who is doing the voting, and it often favors answers that are just more, charming or helpful on the surface, not necessarily the ones that are the safest or most factually accurate.
Okay, so all of this brings us to the final piece of the puzzle, what many experts believe is the gold standard for grading an AI, and that is building your very own custom benchmark, the ultimate test that is tailored to the exact job you need the AI to do. The logic here is so simple, but so powerful. If you're building an AI for doctors, you don't give it a test on American history.
You give it real medical problems. You test it on thousands of anonymized patient questions and tough diagnostic cases. You measure it against the only thing that actually matters. Does it work in the real world for the people who need it?
So how do you actually do this? Well, the best practice is really a four-step process. You start with those standard benchmarks to get a basic idea of what the model can do. Then you zero in on what your specific use case needs. You start building your own tests using real data, real questions from your users, especially those tricky edge cases. And finally, you pull it all together with a multi-layered grading system. Some automated metrics, some human review, and, this is critical, feedback from actual experts in that field.
So let's wrap this up. What's the main takeaway here? Well, first, there's no single IQ test for an AI. It just doesn't exist. Those standard benchmarks, they're a good place to start, but they are not the final word. And these creative methods, like the AI arenas, they give us a whole different, very human perspective. At the end of the day, trying to find the single best AI is, well, it's kind of pointless. The real question is, what's the best model for the job you need it to do?
And that really leaves us with a huge question to chew on. As we get better and better at making these tests, are we actually creating smarter AIs? Or are we just getting really good at training them to be amazing test takers? The answer to that question is probably going to define the entire future of AI.